Hello everyone. Welcome to the live session for Structure, Form and Architecture, the Synergy. This is an NPTEL course by Professor Shubhajit Sadikhan, IIT Roorkee. I am Shreya Shukla. I am the NPTEL TA for this course. Today we will be doing assignment 3 for week 3. We will wait in the call for 5-10 minutes for others to join, and then we will start the session. Thank you. So we have waited for 5 minutes. I'll start with the session. People can join in between. So again, welcome to the live session for Structure, Form and Architecture, the Synergy. This is an NPTEL course by Professor Shubhajit Sadikhan, who is a professor at IIT Roorkee. I'm Shreya Shukla. I am currently doing my PhD at IIT Roorkee and I'm the NPTEL TA for this course. In these live sessions, we do previous year questions where each week assignments of the previous year of the same week are done. So today we will be doing week 3, assignment 3. So before starting the course, I'll quickly go through the terms: structure, form and architecture, and synergy, the 4 terms that are in the name of this course. So structure means a lot of things, of course, as per the English language, but we are concerned with the meaning of structure in terms of architecture. So in architecture, it refers to the system in which is used to support and transmit possible loads on the building to the ground. It gives stability, it resists stresses and strains. Form, in architecture, again, form also has a lot of meanings. In general, form means the shape, or you can say the 3D object. But in terms of architecture, a form is a 3D object or building that is perceived by a viewer in space and time and made possible by the action of light and shadow. And architecture is the art and technique of designing and building. Synergy, synergy means the interaction or cooperation of 2 or more organizations, substances or other agents to produce a combined effect greater than the sum of their separate effects. So the course structure, form and energy, structure, form and architecture, the synergy basically means in this whole course it has been taught the importance of the amalgamation of structure, form and architecture together. So the syllabus for week 3 is basic structural properties, structural requirements, structural arrangement, structural forms and shapes, structural materials. So 5 modules were covered, and these were the topics for the 5 modules. It was entirely mostly about structure. Without any further ado, we will start with the questions. Force is an action on an object that tends to change the shape of the object, move the object, change the motion of the object, all of the above. So in mechanics, force is any action that tends to maintain or alter the motion of a body or to distort it. In physics, force is an influence that causes the motion of an object with mass to change its velocity, that is to accelerate. It can be push or pull, and it always has magnitude and direction. The concept of force is commonly explained in terms of Isaac Newton's 3 laws of motion, which we all studied in our class 9th and 10th. The SI unit of force is Newton, and it is represented by the symbol F. Force is an external agent which is capable of changing a body's state of rest or motion. The force has different effects, and here are some of them. Force can make a body that is at rest to move. For example, if there is a stable object, if you push it, it can move. It can stop a moving body or slow it down. You can stop a moving ball and you can stop it down with force. It can accelerate the speed of a moving body. For example, it's a ball and you kick it, so you can accelerate the speed of it. It can change the direction of a moving body along with its shape and size. So, for example, the ball is coming this way and you kick it in this direction, it changes the direction of the moving body. If you press the balloon, it changes the shape of the moving body. If you pull a spring, it changes the size of that spring. So these are some of the ways force has effects on different objects. And these are some of the examples. For example, a spring becomes longer when it is stretched. A plasticine becomes flat when it is pressed. A can becomes dented when it is hit. A sponge becomes smaller when it is squeezed. And a balloon changes shape when it is pressed. Again, if you see this, there is this object, and when you put force on it in this image, you can see there is motion. Also, if you pull the object, then also this is motion. So motion can occur on an object if the force is pushed, put it in the form of pushing or pulling, or both together. Then this, in this example of cricketer, batsman. So a ball is coming in one direction, he hits the ball with his bat and it changes the direction. So the ball changes the direction and it moves away from the batter. And then this is an image which explains tug of war game, in which there is a rope and two people are pulling it, and it is a balanced force because both the people are pulling it towards them with exact forces. So it's a balanced force. When either of them would have more or less force, the person would get, for example, the woman in yellow shirt, if she puts up more force, then the woman in pink will get pulled on the other direction. So right now, if they're not moving in their states, it's in the state of balance forces. So our answer was that force is an action on an object that tends to change the shape of the object. Yes, it tends to change the shape of the object. It moves the object. Yes, it moves the object, as we saw in the example of pushing and pulling a box. It changes the motion of the object. Yes, if a ball is there and if you kick it, it can change the motion of the object from still to moving. And if it's a moving ball and if you push on it, press on it, then you can change the motion of the ball from moving to pause. So the answer is all of the above. A force is an action on an object that tends to change the object, move the object, or change the motion of the object, and it also changes the direction of the object. Question number 2. What should be the weight of the box be to obtain static equilibrium in the following case? So this diagram has been given, in which there is a seesaw, in which one side A has weight 50 kg, which is kept at 8 meters from the pinpoint, and a B object is kept at 2 meters from the pinpoint, and you are asked to find out what is the weight of the object B so that this whole system stays in equilibrium. So before solving this question, we will quickly see what the terms mean here. So in the state of static equilibrium, the resultant of the forces and moments is equal to 0. That is, which means that the vector sum of the forces and the moments add to 0. Equilibrium means that it does not have motion or rotation. So when we come back to this image, so this whole case, it would be said to be in static equilibrium if the base stays balanced and it does not move in either direction, and it stays balanced like this. So to stay in that static equilibrium phase, the horizontal forces have to be 0, the net horizontal forces have to be 0, the net vertical forces have to be 0, and the net moments have to be 0. So what is moment? The turning effect of force is known as moment of force. The moment of force is a measure of its tendency to cause a body to rotate about a specific point or axis. The torque, the moment, or the moment of force, it is called the torque, it is called moment, or the moment of force. So moment in terms of equation, it means the force into the distance, and in terms of understanding, the moment of force is a measure or of its tendency to cause a body to rotate about a specific point of axis. For example, this is the point and this is your object. So with the moment basically means that the tendency by which you can actually rotate this. You can cause a rotation in an object by the force applied at a distance. So in order for a moment to develop, the force must act on a body in such a manner that the body would begin to twist. This occurs every time a force is applied so that it does not pass through the centroid of the body. A moment is due to the force not having an equal and opposite force directly along its line of action. It is the product of the force multiplied by the perpendicular distance from the line of action of the force to the pivot or point where the object will turn. SI will turn. The SI unit is Newton meter. So it basically means is that this is the pinpoint, this is the pivot point, and this is the object, and this is where you are putting the force. This is your line of action of force. So when the line of action of force is different from the pivot point, it causes the object to either twist or move, and this tendency to cause the body to rotate about a specific point is understood as the moment of force. So for a body to be in static equilibrium, the total moment of the system has to be 0. So For example, this. For example, uh, when we are trying to screw this up tightly, there is a distance of the wrench from the screw. So when we put force on it and it's from a distance, it causes the object to rotate, which is the moment of that system. So coming back to our question, which was that our question was that what should be the weight of the box be to obtain static equilibrium in the following case. So I have explained what it means for a body to be in static equilibrium and what is the force and what is moment. So coming back to keep the moment zero, which means that, for example, I have added a figure here to explain what is static equilibrium equation for it. So consider the pivot point to be A, and then at point P1 and point P2, force F1 and F2 are generated. And point P1 is at a distance of D1 and point P2 is at a distance of D2. So the tension at point P1 will be F1 into D1, force into distance. And the moment at point P2 will be F2 into D2, force into distance. And according to the equilibrium state, the total moment, the net moment has to be 0. So T1 plus T2 should be equal to 0. Now when we write this equation, because F1 will be in clockwise direction, we write so one of the forces, F1 and F2, one would cause the body to rotate in the direction of anti-clockwise, and F1 will cause the body to rotate in the direction of clockwise. So that's why one of the forces has to be written into negative, because the direction of the forces are changing. So the equation becomes F minus F1 d1 plus F2 d2 equals 0, which means F1 d1 equals F2 d2. Now coming back to the image that has been given here, if we put this equation on this question, F1 d1 equals F2 d2, which means that 50 F1 in 50 into 8, which is the weight A and the distance 8 meter from the pivot point, is equal to the distance 2 meter into the weight of the box B. So, and then moving around the equation, we get B equals 400 by 2, which means B equals 200 kgs. So our answer is the weight of the box B should be 200 kgs for the system to obtain static equilibrium. Coming to question number 3, what type of force is acting towards the direction of arrow in the given example? Compression, shear, tension, or torsion? So one image has been given of a figure, and we are being asked that what type of force are acting towards the direction of arrow in the given example: compression, shear, tension, or torsion. So I'll quickly explain all these four types of forces. So compression force or compressive force occurs when a physical force presses inward on an object, causing it to become compacted. In this process, the relative positions of atoms and molecules of the objects change. This change can be temporary or permanent depending on the type of material receiving the compressive force. So what happens in compressive forces, for example, we take this bottle. If I push it like this, it gets compacted. Because it's a plastic bottle, it gets compacted. This is compressive force when I'm trying to put compression on it. Then shear force. Shear force is acting in a direction that's parallel to, over the top of, a surface or cross section of a body, like the pressure of airflow over an airplane wing. The word shear in the term is a reference to the fact that such a force can cut or shear through the surface or object under strain. Then tension. Tension is described as the pulling force transmitted axially by the means of a string, rope, chain, or similar object, or by each end of a rod, truss member, or similar 3D object. Tension might also be described as the action-reaction pair of forces acting in each end of said elements. Torsion. Torsion, if a torsional load is applied at a material, it will create shear stress, which induces torsional force. If this force is large enough, it can cause the material to twist. The twisting force is called the torsional force. So coming to the examples, uh, here we have given some images have been added. So what happens in tension force or tension stress? The body is stretched. So when we stretch somebody, it causes tension force. When we press somebody, it causes compression stress. And when we try to put the force on the body parallel to its axis, it causes shear stress in it. For example, and then a few of more of the examples given here of compression. Putting compression on spring causes it to compact. Twisting the material causes a cloth causes compression. And then tension, tug of war. And to explain it in another way, 4 objects here showing the 4 kinds of forces that are being put on it, and how the forces are changing the shape of the body. So if for example, there is a cuboid, imagine, and when we put tension on it, it gets elongated. When we put compression on it, it gets compacted. When we put shear force on it, it shifts from its angle. And when torsional force is put, it gets twisted. So our question was, what type of force is acting towards the direction of arrow in the given example? So as you can see, two different arrows are shown, and the body is being diverted into 2 parts, just like the example we see here of shear force. So our answer is B, shear force. So our answer is B, shear. Coming to question number 4, lateral instability in a structure is also known as buckling, displacement, stiffness, or rigidity. So I'll quickly go through these terms. So geometric stability, it is necessary to guarantee a stable equilibrium. It is defined as a property of a structure which preserves its geometry under loads and allows the structure to act as a unified system. So the stability is a property of a structure which basically preserves the geometry of the structure under different loads. Stability is broadly defined as a capacity which can resist displacement, overturning, collapse, and buckling. So what is buckling? In structural engineering, buckling is the sudden change in shape of a structural component under load, such as the bowing of a column under compression or the wrinkling of a plate under shear. It is also called lateral instability. So when axial load is applied along the direction of neutral axis and a column, due to load, it may bend. That is called buckling. Displacement in the building from one position to another due to an external force like wind or earthquake. So displacement in terms of geometric stability, it can be explained as the building displaces from its point. For example, when because of wind we have forces on the building, and we have learned, we all know that the structures, even though in few millimeters or centimeters, they tend to move a little. So that is displacement of the building from its position because of the forces that are being applied on it. Stiffness is the extent to which an object resists deformation in response to an applied force. The complementary concept of flexibility or pliability is stiffness. The more flexible an object is, the less stiff it is. So stiffness means that the force is resisting deformation when a load is applying on it. For example, there is an object and you apply a load on it and the object is not changing its shape. That is what stiffness means. It is the opposite of flexibility. Flexibility means that you put pressure on an object and it changes shape, but it comes back to its shape also. Then rigidity. Rigidity is the property of a structure that it does not bend or flex under an applied force. So our answer is buckling. Lateral instability in a structure is also known as buckling. So buckling is the so stability can be defined as a capacity to resist in terms of structures, and it resists to resist displacement, overturning, collapse, and buckling. And when we come to the definition of buckling is also called lateral instability. And it is called lateral instability because buckling basically means the change or the bowing of a column under compression. So because the column is being bent in buckling, not beams. In buckling, the column is being bent. When beams are being bent, it is called bending. So columns are being bent, that's why it's called lateral instability, because it's lateral. The columns are considered lateral, not horizontal. Columns are lateral and beams are horizontal. So when lateral body turns into bow shape because of the applied force, that's why it's called lateral instability. So our answer is buckling. Question number 5. In a pin type structural support, then 4 options have been given. Horizontal movement is free, but vertical movement is fixed. Horizontal movement is fixed, but vertical movement is free. Both horizontal and vertical movement are fixed. Both horizontal and vertical movement are free. So to be able to answer this, we will have to know what is a pin type structural support system, and I'll quickly tell you about that. So pinned supports are also referred to as hinged supports. It is the most common type of support in civil engineering. A pin support does not allow the movement either vertically or horizontally, but it allows rotation. So in the structural systems, support systems, there is one question in the next one of the questions in the upcoming questions. There is one question which clearly defines the different kinds of supports or connections. So all these supports and connections, they are differentiated on the basis of their movement vertically, their movement horizontally, and their movement of rotation. So I will explain that clearly in the coming questions. So a pinned support cannot cause horizontal motion, it cannot cause vertical motion, it can only cause rotation. So a pinned support can resist both vertical and horizontal forces, but not a moment. They will allow the structural member to rotate, but not to translate in any direction. In most cases, a pinned support only allows for twisting in one direction. So I have added few examples of pinned supports. So as you can see, all these examples, they have a pin that is attached between two objects so that the object can move from here to here. So in pin supports, the horizontal movement is fixed, vertical movement is fixed, only rotation is allowed. So there is supposed to be a pinned support here on which the rotation can happen. So there is a member, there is support, and there is a pin, and the pin allows for the member to move. So our answer is, in pin type structural support, both horizontal and vertical movements are fixed. None of them translate. Question number 6. In which of the following structural support type the rotation is free? So the answers are roller, pin, both A and B, D, none of the above. So there are 3 main types of support systems: roller, fixed, and pin. So we just talked about pin, and I will quickly describe the roller and fixed supports also, and I will also show a few examples. And we are being asked that in which of the following structural support types the rotation is free. So coming to rollers. Roller supports are free to rotate and translate along the surface upon which the roller rests. Roller supports are commonly located at one end of long bridges. This allows the bridge structure to expand and contract with temperature changes. The expansion forces can fracture the supports at the banks if the bridge structure was locked in place. Roller supports can also take the form of rubber bearings, rockers, a set of gears which are designed to allow a limited amount of lateral movement. Fixed supports resist vertical and horizontal forces as well as moment. Since they restrain both rotation and translation, they are also known as rigid supports. This means that a structure only needs one fixed support in order to be stable. All 3 equations of equilibrium can be satisfied. A flagpole set into a concrete base is a good example of this kind of support. And in pinned supports, they can resist both vertical and horizontal forces but not moments. They will allow the structural member to rotate but not to translate in any direction. The knee can be idealized as a connection which allows the rotation in only one direction and provides resistance to lateral movement. So, in roller supports, horizontal movement, for example, this is one element, this is one member, and they both have a roller connection, roller support. So in roller support, you have bearings or other kind of things which allow the horizontal movements, and they also allow the rotation. In fixed supports, you are not allowed horizontal movement or vertical movement or rotation. All three things are not allowed. In pinned supports, you are not allowed horizontal movement or vertical movement, but you are allowed rotation. So this is the difference between three kinds of supports. These are the examples. So example 1 is fixed support. It's a steel column fixed in concrete. It cannot be moved horizontally, vertically, or it cannot be rotated. Then next is an example of a element of bridge. You can see a human next to it. So if you can see the connection, it does not allow it to move horizontally or vertically, but it is allowing it to move. It is allowing it to rotate. Then in the third example, we have the roller kind of example. We have bearings on it, because of which because of the bearings, it can move a little in the horizontal direction and it can also rotate. The mechanism is such that. To give a better example, to sum it up together, we have support system, the movement it is allowed in, and restricted movement and reaction forces. So in fixed support, movement is allowed in no direction, and movement is restricted in vertical, horizontal, and rotation. And in pinned supports, rotation is about the supported location, and the movement is restricted in vertical and horizontal. In roller support, the movement is allowed in horizontal direction and rotation about the supported location, but it is restricted in vertical direction. So our answer is both A and B. So in roller and pin both, the rotation is free. In fixed, it is not free, but in roller and pin both, the rotation is free. So the answer is both A and B. Coming back to the next question, question number 7. St. Louis Gateway Arch in USA is an example of formative, semi-formative, non-formative, or none of the above shape. So this is how the St. Louis arch looks like. St. Louis Gateway Arch in USA looks like. It is a 192 meter tall monument. It's located in St. Louis, Missouri, United States. It is clad in stainless steel. It is built in the form of a catenary arch. It is world's largest, sorry, not largest, but tallest arch. It is world's tallest arch. It was built in 1965, and the architectural style of this building is modern architecture and high-tech architecture. It was designed by architect Eero Saarinen. So before we answer the question, I'll quickly go through these concepts, the form active, non-form active, and semi-form active concepts. So the form and active concept is an essential aid for assessing the efficiency of a structural form. Using this concept, all the buildings and the structures that support them can be placed into one of the three categories, which indicates the type of internal force that will occur between them. So this concept of form and active concept it basically indicates the type of internal forces that will occur within them. So for example, there is a building and it has a structure, okay, or there is a structure. Just let's take the structure. So the kind of forces that act on this structure, because of the shape of that structure, it will have some internal forces. So the load that is being applied on that structure, so the type of internal forces that are generated in a structure because of its shape is can be divided into three types. So these three types are form active structures, non-form active structures, and semi-form active structures. So this idea basically means that there's a structure, it has certain shape. It can be post-lintel, it can be arch, it can be some staggered structure, it can be a structure in any shape, okay? And when a load is applied on that structure, or for example the dead load itself, that structure will have some internal forces to resist that load to achieve stability. So that internal forces that occur within the structural system, it can be divided in three parts. So in form active structure, what happens is that form active structures only have compression and tension forces. They do not have bending forces. For example, if there is a shape, for example, a structure is in certain shape, structures like domes and arches and cable nets, tension fabrics, they are shaped such that they have such shape that they don't have any bending moment. They only have compressive forces and tension forces. Because of the shape, their bending moment is zero. In non-form active forces, there is no compression or tension, there is only bending. And it is only bending because it has beams like structures. For example, beams. When force is put on beams, they bend, right? They bend. So these are non-form active subjects in which only bending moment is there, but no compression or tension. And then the third category, semi-form active, it basically means that it has both. It has some part which has bending stresses and some part have your uh, tension and compression stresses. It is neither post or beam or form active. So the elements therefore contain full range of internal force types: axial thrust, bending moment, shear force. Semi-form active refers to elements that combine bending and axial stresses. So when we go back to this, so we just learned that the form active structures are structures like domes, arches, cable nets, tension fabrics, because they don't have bending stress, they only have compression and tension stresses. And non-form active concept, the buildings that fall under it are structures with simple beam-like structures, post-beam structures, which have only bending stresses and not compression and tension stresses. So when we go back to this building, it's clearly an arch. So it will fall under form active concept. So our answer will be that the St. Louis Gateway Arch in the USA is an example of form active shape. Question number 8. In an object, the property of the material having ability to deform without fracture is called toughness, hardness, brittleness, or ductility. I'll quickly explain all the four terms. So toughness means the ability of a material to resist fracture when stressed. Amount of energy absorbed per unit volume. Stress means amount of energy absorbed per unit volume. It is the ability of a material to absorb energy and plastically deform without fracture. Hardness, it is the ability of a material to resist permanent deformation under a sharp load applied on structure. It is also referred to as stiffness or temper. It provides resistance to bending, scratching, abrasion, or cutting. The greater the hardness of the material, the greater the resistance it has to deformation. Ductility is the property of a material having ability to deform without fracture. Materials with high ductility is preferred as they are more able to indicate structural failure without a sudden collapse. Brittleness is the property of a material where materials break easily without significant deformation. Materials with brittleness absorb relatively little energy prior to fracture, even those of high strength. So our question was, in an object, the property of the material having ability to deform without fracture is called ductility, because ductility is the property in which the ability to deform with fracture is there, and materials with high ductility are preferred as they are more able to indicate structural failure without a sudden collapse. So what this basically means is that if a material is ductile and it is being used in structure, so it will not suddenly collapse, okay, because it will not suddenly collapse when force is there. It will first deform and then collapse. So when this deformation occurs, that can indicate, that can warn about the structural failure, and it will not suddenly collapse. So when that indication of the material occurs, or that structural, that there can be a structural failure, that can be used to assess the damage and avoid the damage instead of a sudden collapse. Whereas in a brittle material, it will suddenly fracture when enough force is applied to it without deformation. So the answer is ductility. GFRC, used in building construction, stands for gypsum flow fiber reinforced concrete, glass fiber reinforced concrete, glass fiber reinforced glass fiber reinforced concrete, glass free reinforced concrete, gypsum free reinforced concrete. Excuse me. And then fourth is gypsum free reinforced concrete. So I'll quickly tell you about GFRC. GFRC, the full form for GFRC that is used in construction is glass fiber reinforced concrete, and it comprises of hydration products of cement or cement plus sand and the glass fibers. Glass fibers are used as reinforcement for concrete. So in glass fiber reinforced concrete, what happens is, it's a concrete mix made up of cement, sand, and for reinforcement in this material, glass fibers have been put. So GFRC is a material that is building a substantial influence on the economics, technology, and aesthetics of the building industry worldwide for over 40 years. GFRC is one of the most multi-purpose structures tools obtained to architects and engineers. And glass fibers are available in the form of continuous rovings, chopped strand mats, trinet wool ropes, or woven fabric. So glass fibers are actually fibers which can be available in the form of ropes, wools, strained mats, or a woven fabric. I'll show you an image and then you will get the clarity of what it actually is. GFRC has a wide variety of applications. It can be used to fabricate interior countertops, floors, fireplace, mantles, exterior window surrounding elements, facade wall panels, and others. And on an average, GFRC has 4 times 4 more flexural strength than does conventional unreinforced concrete. This means that GFRC is stronger and more flexible, while ordinary unreinforced concrete is weaker and more brittle. So we have concrete and we have reinforced concrete and we have GFRC. So concrete is just cement and sand mixture with water. Reinforced concrete is cement sand mixture with water, in which there is also steel for reinforcing the building. Then we have GFRC, in which the reinforcement instead of steel is being given by glass fibers. So GFRC is considered to be 2 to 4 times more flexible than the normal concrete. It means that it is more stronger and it is more flexible than the regular concrete. So this is how GFRC actually looks. So we have concrete and then we have GFRC shear grid. You can see the red mesh there, that's made of GFRC. And then this is a component example. So it's like this. There's concrete and then there is some GFRC either added in the form of mesh, for example in the image 2, or in the form of threads. For example, in the image 1 you can see some threads coming out of that image. So it can be added in the form of long threads or in the form of mesh. So our answer is glass fiber reinforced concrete. Coming to question number 10. Arrange the following forms from high to low structural efficiency. Trussed portal, steel truss, shell, and RCC slab. So what is a trussed portal? It is a common portal truss structure, and it is comprised of a set of braced columns that support an overhead truss. And then what is a steel truss? A steel roof truss is essentially a triangulated system of straight interconnected structural elements. The individual elements are joined at the nodes by welding. Then shell structure. It's a thin covered plate structure shaped to transmit applied forces by compressive, tensile and shear stresses that act in the plane of the surface. Then what is an RCC slab? It's a structural component. RCC slabs are supported on columns and beams. Now this image, I'll put it on full screen for you to see clearly. So this image gives the structural efficiency based on the structure form and structure concept in which I discussed in the previous question, that if it's form active, if it's semi-form active, or it is non-form active. So on the top part are with low structural efficiency, and in the bottom it is with high structural efficiency. So non-form active structures have low structural efficiency. For example, the trusses in normal forms, or you can say slabs and other things. Then we have semi-form active, in which all three kinds of forces are there: compression and tension and bending moment. And these are basically some modification has been made to the non-form active shapes, because of which it improves the structural efficiency because of the change of shape, and thus it becomes more structurally efficient. And then we have form active, which contains arch or shell or tensile membrane or cable net. So our question was, arrange the following forms from high to low structural efficiency. So हमें पहले देखना है सबसे high किसकी है. Our options are trussed portal. So I have added one image of trussed portal here, and yeah. So trussed portal means a common portal truss comprised of a set of columns that support the set of braced columns that support an overhead truss. So what happens in trussed frame is that there are columns and then there is a truss over it. And in portal frame truss, what happens is that the columns are also braced, that the columns also have braces. So coming back here, so we just saw in the image that the curved forms like arches and domes and shells have really high structural efficiency, and our question asks to arrange from high to low. So R would be on top. Then we will have trussed portal, because in trussed portal the columns also have braces compared to a normal steel truss. So we will have P. Then we have steel truss, which is Q, and then last we will have RCC slab, because it is non-form active and it has the least structural efficiency. So our answer is C, R, P, Q, S. Coming to question number 11, I have total 10 questions for today, and then if anybody has any questions, you can ask them. So I have 5 more questions left for today. An object is said to be in static equilibrium when net horizontal forces must be equal to 0, net vertical forces must be equal to 0, net moments must be equal to 0, or all of the above together. So I explained it in the previous question also, and I will quickly explain it again, that in a state of static equilibrium, the resultant of all the forces and moments must be equal to 0. That is, that the vector sum of the forces and moments adds to 0. Equilibrium means that it does not have any motion or rotation. So net force on an object is 0 in the state of equilibrium, which means that summation H is equal to 0, which means net horizontal forces must be equal to 0. Summation V equals 0, which means that net vertical forces must be equal to 0 and summation m equals to 0, which means net moments must be equal to 0. So our answer is all of the above. An object is said to be in static equilibrium when net horizontal force is also 0, vertical forces are also 0, and net moments are also 0. Question number 12. The structural arrangement of Villa Savoy, France is post beam, post lintel, post slab, or wall slab. So this is what Villa Savoy looks like. It's a modernist villa. It was designed by Swiss French architect Le Corbusier. It was built between 1928 and 1931 using RCC. And an example of it's an example of Le Corbusier's 5 points for new construction, which includes pilotis, roof garden, open floor plan, long windows, and open facades. So Le Corbusier gave these 5 points of new construction in one of his theories, one of his concepts, which included that these 5 elements should be there. One was pillars, as you can see in the ground floor, the pillars. Then roof garden. So this building has a roof garden. Then open floor plan. As you can see, the ground floor is all open floor plan, and then long windows. You can see on the first floor it's a long ribbon window with no interruption from structural or wall members, and then open facades. So which again, coming to the ground floor, you see an open facade and only pillars there. So it's a renowned example of international style. So quickly talking about the different structural system. So wall slab structural system means that the wall acts as the vertical load bearing member and slab acts as a horizontal load bearing member, which means that in any kind of structure, these kind of structures, we have one vertical load bearing member and one horizontal load bearing member. So in wall slab structural system, walls become the vertical load bearing member and the slab becomes the horizontal load bearing member. In post lintel, column acts as a load bearing member and lintel acts as a horizontal load bearing member. In post and beam, column acts as vertical load bearing member and beam acts as a load bearing member. And in post it's very similar to one of the previous.
इसमें सत्तू मिला दीजिएगा आलू में। इसको तो रखिए अंदर और आलू जब निकालेंगे ना उसी के साथ आलू भी डाल दीजिए उसमें सत्तू आलू दुकान लगा देंगे सब उस दिन वाला वो पका हुआ था ना